Now move to the three-dimensional structure from two-dimensional hexagonal structure, right? So first I am going to write here the two-dimensional hexagonal structure, arrangement of atoms, right? So here that is AB type. So A type. Now it is B type. Now again a B type layer I am going to make. So this is the A, B, A. So it is the arrangement of particles AB type. It is two-dimensional. Now for the three-dimensional, just place a layer over this, the third layer, to make it three-dimensional, right? So I am going to put here the atoms from the upward direction, right? So, and that is AB type, means different type. So here the third layer comes. This, and this. So this is the third layer atoms over the two-dimensional arrangement, and this forms the three-dimensional structure. And this is the arrangement of atom is AB type, means two-dimensional hexagonal structure, close-packing structure. If you are going to observe here that by placing the above layer to make it three-dimensional, two types of voids formed here. One is this type, the vertex upward, right? And here also vertex upward, but one is here formed, this, the vertex downward, right? So two types of voids, two voids having vertex upward, and one void with vertex downward, right? And when we are going to place the third layer over this two-dimensional structure to make it three-dimensional, the voids upward, facing upward, the vertex facing upward change to tetrahedral voids. So it is the voids with vertex upward voids change to the tetrahedral void. Tetrahedral void means in which it is formed by four atoms. Let us explain more about this. One atom, here is two atom, and here is the three atom, and this is the void vertex upward, void with upward vertex. Now if you are going to place one atom from the upper side, right, this is the atom, you are going to cover it from the upward direction. Now from the below direction, if you are going to see, it is actually a tetrahedral void. So this is the tetrahedral void. So tetrahedral void formed from the two-dimensional upward vertex voids, right? Now in this, the tetrahedral void, to make the tetrahedral void, four atoms are used. So this tetrahedral void is surrounded by four atoms, right? Now if you are going to observe this downward vertex void, So, one atom, two atom, and here is the third. So this is the vertex downward void, right? If you are going to place the atom from the above direction, so this is like this. So this is one atom here, one atom here, and one atom here. So if you are going to observe that this triangular void with downward direction vertex change to this 6, and upward when you are going to see from the downward octahedral void, it is this void is octahedral void, and it is surrounded by 6 atoms, 3 upper side, 3 lower side. So surrounded by 6 atoms. So one tetrahedral void with downward vertex change to octahedral void by placing third layer, right? These the vertex upward voids change to tetrahedral void. These are two vertex upward voids, means 2 voids with upward vertex changes to tetrahedral void, right? And one tetrahedral void with downward vertex changes to octahedral void when placing the third layer, right? Now come to the coordination number in 3-dimensional structure made from the 2-dimensional hexagonal close packing structure in this, right? That is 12. And how it comes the 12? That one is hexagon there. Let me make the hexagon here. 1, 2, 3, 4, 5, and 6. Here is the hexagon. Hexagon. Now the upper layer facing downward. Now the downward layer facing upward. This, right? So this hexagon, the center atom touching 6 spheres, 6 atoms of same layer. 6 atoms of same layer, right? 3 atoms of upper layer, and 3 atoms from the lower layer of lower layer. This is the touching of an atom. Right, now here is the coordination number is 6 plus 6 plus 3. So 6 plus 3 plus 3 is equal to 12, the coordination number. Right, so this is all about how the 3-dimensional cubic close packing structure formed, and from the 2-dimensional hexagonal close packing, and we have discussed from the 2-dimensional star close packing structure. So now move to the 3-dimensional cubic close packed structures, types of 3-dimensional cubic close packed. Now the types of 3-dimensional cubic close packed structures. It is of 3 types. The first is hexagonal close packed structure, we have discussed. Now the second is face centered or CCP structure, face center cubic unit cell, or cubic close packing structure. And the third is BCC type, body center cubic close packed structure.